In this lesson, we're going to improve our LLM's capabilities by structuring our outputs. A word of warning, this lesson features a lot of code. If you're uncomfortable with code, just focus on the takeaways that I discuss instead of the code itself. This is our third of 3 steps. In the last lesson, we engineered our inputs to improve the quality of the model's responses. In this lesson, we'll improve quality instead by constraining our outputs. If you haven't already, go to this URL to open the starter code that I've written for you. If you have your notebook from the last lesson still open, use the same notebook. If you're opening this notebook for the first time, at the top of the file, click Run All. The first 2 steps will take about 5 to 10 minutes, so you can continue watching this walkthrough in the meantime. Recall from our open source demo, Llama 8 billion failed to complete our task. The output's format and accuracy were both off. Let's reproduce this result again. In your notebook, scroll down to the Structure Outputs demo, hover over example A, and click Run. You'll get this blob of text. It's both wrong and incorrectly formatted. We want a list of true or false. To fix this, in the previous lesson, we applied 3 tips. Be specific, provide examples, and ask for chain of thought. After applying these tips, Llama produced the correct outputs, true, false, false. However, correctness came at a cost. The original prompt took 288 characters. However, the new prompt takes 1,312 characters. That's a whopping 4.5 times longer input. That's a lot of inputs. So, can we improve output format and correctness without increasing the number of input tokens? And the answer is, of course, yes. Let me explain. Here's the LLM. It takes text as input and produces text as output. In this case, our input is "Are bananas fruits?" And unfortunately, the LLM outputs "are." That's not even a valid response to the question. To fix this, we force the LLM to output only yes or no. That way, even if the output is wrong, at least the output is valid. To do this, we need to modify this step at the end, how LLMs translate outputs into words. Let's zoom in. The LLM actually first outputs a list of numbers. These numbers are actually probabilities that correspond to certain words. In our example, the first probability is the likelihood of yes, the second, the likelihood of no, the third, to are, and the last, to is. The highest probability is 60%, and the corresponding word is are, so we finally output are. This is how the LLM predicts normally, but our goal is to output only yes or no, so let's make some changes. First, disregard all other words. Consider only yes or no, and we now take the higher probability, 10%, which corresponds to yes. Finally, we output yes. And with that, we've successfully constrained our LLM to output only yes or no, taking the highest probability valid word. In this example, we only wanted yes or no, so we used the probabilities of these 2 words and simply picked the more probable of the 2. Now our LLM is forced to output yes or no, and more importantly, we did this without changing the number of input tokens. Navigate back to your notebook and scroll down to Step 0 Setup. Mouse over the cell and click Run. You won't see any output for the step. You're now set up. For our first example, we will force true or false. Equivalently, we can say that we'll force a boolean. A boolean is just true or false. For example 1, we ask the LLM, "Are bananas fruits?" and force the output to be true or false. Now, hover over example 1 and click Run. This will output a single boolean, true. This is correct. Bananas are fruits. For our next example, we'll force 3 booleans instead of just 1. Now, we check if bananas, almonds, and potatoes are fruits. Move your mouse over example 2 and hit Run. Now, you'll see the outputs, true, false, false. This is correct. Now let's see if we can use this to constrain the output format for our non-food critiques. Hover over example B, then click Run. And this outputs 3 booleans. The output format is valid. Unfortunately, the output is still wrong though. It should be true, false, false, not true, false, true. So let's keep going. For our third example, we will force the model to reason step by step. For this step, we'll prompt the model to reason first, then force the model to output text between think tags. You can choose whatever format you want for thinking. This is just the format I chose. Like before, the prompt is to check whether bananas, almonds, and potatoes are fruits. Move your mouse over example 3, then click Run. This will take some time to run, about 45 seconds or so. Then you'll see the final output with the correct reasoning, and even better, the correct outputs: true, false, false. Now, let's apply the same structured outputs to our example project for non-food critiques. Hover over example C and click Run. You'll see the reasoning as well as the correct answer at the end. Now, by structuring our outputs, we've improved the quality of our model and forced the outputs to match a specific format. That's a win-win. We've also drastically shortened prompt length. The original prompt was 288 characters. From the last lesson, we needed 1,312 characters. From this lesson, we only needed 386 characters, along with structured outputs, to achieve the correct answer. With prompt engineering, we needed a 4.5 times longer prompt to produce the right outputs. With structured outputs, we have a much shorter prompt, just 1.3 times longer. And we're guaranteed the output will always be valid. This isn't to say that one is better than the other, but I want to emphasize that prompt engineering and constraining outputs will actually be used together most often to maximize model quality. Now let's try constraining outputs for a proprietary model, namely OpenAI's models as well. Go to platform.openai.com. Your web page will look like this. Make sure to click on Login in the top right if you haven't already. Then click on Dashboard in the top right. Click Create in the center of the page, and you should see a page like this. Click on the Model Picker. From the drop-down, select GPT-5 Nano, and your screen should now look like this. In the bottom right, make sure to select Auto Clear. Then, next to the model name, click on the Settings icon. This will pop up a Settings menu. Click on the Text Format drop-down, and from the drop-down, you can then click Select JSON Schema, so you can set up constrained outputs. Make sure it's JSON Schema and not JSON Object. This will open up a dialog like this one. Paste in the following, which you'll actually get from this URL. Copy the constrained output JSON schema, then paste in the JSON schema here. Scroll to the bottom of the dialog and click on Save. We'll see the JSON schema reflected in the menu here. Then click outside of the menu. From this URL, copy the project example prompt from before. Paste the example project prompt here and hit Run. And now we have the output in JSON format. Try whatever random changes you want to the prompt. The API will always return outputs in this format. And with that, you've successfully constrained outputs for ChatGPT. In summary, structuring outputs forces the output to be valid. We can force yes or no, we can force numbers, we can force any particular format we want for both open source and proprietary models. We've discussed how it works, a simple example to identify fruits, and an improvement for our detection of non-food critiques. That's now the end of our third step. We've seen 2 ways to improve our model's quality without training of any kind. And this concludes our lesson on structuring outputs. And in fact, that concludes our third of 3 steps. And now, you finished just the start of your journey building with AI. These are the first steps that everyone should take for a project involving AI. You can access this URL for a copy of the starter code, other prompts, and more resources. In the next lesson, we'll wrap up the class.